And then you remember Somsum and Nizat, they already decided, they already know what the hell is going on with the number of apples, right? They were like, if I have 14 apples, I can divide it by two groups, and each group will have seven apples. If I have 15 apples, I can divide it by three groups, and each group will have five apples, so on and so forth, right? Um, or the same 15 apples can be divided by five groups, and each group will have three apples. They were smart kids, Nick and Chomsyom, and they found out these little numbers. Then there were a very, very, very smart kid. His name was Shuriya. And that kid, that guy, Shuriya, he was always sure about what he was talking about. That's why they called him Shuriya. Okay. Um, so that Shuriya says that, well, if I have 15 apples, right? If I have 15 apples, I can divide it by three groups, or I can divide it them like this, those signs meaning the exact same thing, right? These things are exactly the same, right? Um, but, but, I can, sorry, not but. He said that I can divide 15 apples by three groups, by five groups, right? I can divide, if I have 20 apples, I can divide them by two groups. I can divide them by four groups. I can divide them by five groups. Each of them will give me some number. I can divide them by 10 groups, right? Each of them will give me some number of apples. If I divide all of them by two groups, I will have 10 apples in each group. If I divide them by four groups, I will have five apples in each group. I will have four apples. I will have two apples in each group, right? That's what the Shuriya came up with. But then Shuriya said, if I have 17 apples, I cannot divide them by any number of groups, right? Because if I divide 17 apples by two groups, in each group, there will be eight apples and one half apple, right? So there is no way of dividing 17 by some number that we can get some integer, right? Because 8.5, we remember from the previous classes, 8.5 is not an integer. And Shuriya said that, you know what? There are some numbers like 17. For example, 19 is also that kind of number. You cannot divide it by anything. Or 23 is also that kind of number. You cannot divide it by anything. Or 25 is also that kind of number. You cannot divide it by anything. But then some said that, no, Shuriya, you can divide 25 by 5. For example, Shuriya was that, hey, Shamsham, you are right. Yes. So 25 is not that kind of number. 25 is not a good number. But for some reason, Shuriya said that 17, 19, 13, 3, for example, 2, you cannot divide them by any number of groups. So you can divide them by only themselves. If you have 23 apples, you can divide them by in 23 groups, okay? Or 23 apples, you can divide them by one group only, right? Nothing else. You can divide them by the number of groups, which is the same with their own number, or number of groups, which is just one. So then Shuriya said that whatever the number is, that Shuriya said that whatever number whatever number, this is a number sign for me, whatever number whatever number that is divisible. Divisible is that we can divide it, right? Divisible um, by, not by, only by itself, like 20 23. You see, itself and one, we will call them good numbers, not just good numbers, very good numbers. We will call them very good numbers. Some said that very good numbers seems like a weird word for a mathematical term. And then Nick said that, okay, let's call them not very good. Very good is a weird thing. Let's call them Optimus. And then the other Shuriya said that Optimus doesn't. What the hell is Optimus? It looks like octopus, right? Then Shuriya said that instead of very good or Optimus, let's call them prime. Then they came up with the prime numbers. So what's a prime number? Prime number is whatever, it's a whatever number which is divisible only by itself and one. That's it. That's how came up with the prime numbers. Then they noticed that any number is just a multiplication of primes. What the hell? Because they were like, let's take 15. 15, what is 15? 15 is 3 times 5. So we multiplied two primes. This is prime, right? 3 is prime because we cannot divide 3 by anything else than itself, and 1. And 5. 5 is also prime. Or like 20. 20 is what? 2 times 10. So 2 is prime. 10 is not a prime. So let's work on it a little more. 2 times, instead of 10, let's write 2 times 5. So prime, prime, prime. So they came up, they noticed a very important thing. They noticed that any number can be represented, can be represented as a multiplication, multiplication of primes. That's a very important thing in mathematics. That choose any number, you can show it as a multiplication of primes. And in the next lecture, we will see how to do so.